So, here's my problem. Calculate the future value of an investment of $12,000 at 7% per annum for 5 years, where interest is compounded annually. So you look for interest paid or compounded or something to tell you that it's compound interest, not simple. Okay, so all I'm going to do is put it into my formula. These are the things I need to know about. Let's see what I've got. A, final amount is what I'm looking for. P is my principal. What am I starting with? $12,000. R is my rate. 7% per annum. I'm working annually, so I'll just leave it as 7%, and I'm going to write it as a decimal, 0.07. Pardon me, if you get stuck on this, just get your calculator, 7 divided by 100, very simple. N, number of terms, in this case number of years, is 5. Pretty straightforward. Let's plug it in. Future value amount is principal times 1 plus R to the n. That's what I'm trying to figure out. Principal is 12,000 times. Now I'm not going to write brackets 1 plus R brackets because in fact this is easy to do. 1 plus 0.07 is 1.07. N, 5 years. Get your calculator. 12,000 times 1.07 to the power of 5. It's got a lot of decimal places. This is a financial thing, so I'm going to round off to the cents. Is $16,830.62. Pretty easy. There may be questions that instead of asking you for the future value, we'll ask you for the interest. If you need to work out the interest, you just get your future value amount and subtract what you started with, subtract the principal. Now that's the opposite of what you do when you do simple interest. For simple interest, you calculate your interest, then you add it on if you want the future value. But for compound interest, you calculate the final amount, and if you want the interest, you subtract 12,000. So the interest here would be $4,830.62. Another example. Okay. All right. Calculate the future value of an investment of $6,000 at 8% per annum for 3 years, with interest compounded annually. Okay, what have we got? Get back to our formula. Let me write the formula here so you can all see it. Amount is principal 1 plus the rate to the power of n. So, A, that's what I'm looking for. P, principal, what I'm starting with, $6,000. R, my rate, again it's going to be a decimal. It's 8% per annum and I'm working annually, so it's just 8%, 0.08. And N, number of terms, well it's annually, so it's the number of years, 3 years. Okay, put those numbers in. Future amounts, what I'm looking for, principal is 6,000. 1 plus the rate's 0.08, so it's 1.08. To the power of n, that's 3. It's not hard. Calculator. Alright, 6,000 times 1.08 to the power of 3. Okay, 7, $7, 558.27. It's actually 272, so we'll round it up to 27 cents. And again, if the question had asked me for the amount of the interest, I would just go this minus this, which is $1,558.27. Too easy. Okay, what happens if it's not annual? Let's go back to this question. Here's my eraser. Okay, it's not annually, then I'm going to have to change a few things. Suppose instead of annually, I make it every 6 months. Okay? Instead of compounding annually, I'm going to be compounding every 6 months. What has to change? Well, the rate and the number of terms have to be terms, not years. So let's have a good look. It was 7% per annum. So what's the interest rate every 6 months? Well, isn't it 3.5%? So this number is now going to become 0.035, 3.5% per term. And this number is the number of terms. Well, instead of being 5, it's 5 years. How many lots of 6 months are there in 5 years? There are obviously twice as many, 10. So I'm going to go back over here, put the new numbers in, and I'm going to get a new answer. Actually, I should write that last number down. It was 163. Let me write this number down back here. 1683062. I just want to leave that so I can compare it, so you can see what happens when we do it this way. Okay, the new amount, the new interest is 3.5%, and we're doing it twice as many times. Okay, let's get our calculator out. 12,000 times 1.035, power of 10. It is 16927, and it's 185, so I'm going to round up to 19, because the bank will do that. Okay, so if I use every 6 months interest instead of every year, sorry, if I get paid interest every 6 months, not use it, then I end up with half the rate twice as many times. And look at the difference in figure. This was, if it was compounded per year, I'm not writing very well here. This was compounded annually. Okay. Annually it was 16830, and here it's almost 16930. An extra $100 just for getting interest compounding every 6 months. And that will happen in general. The more often you compound, the better it is for your bottom line. In fact, some banks pay interest monthly or even daily. And when you get to monthly and daily, you have to be very careful not to round these numbers off. You've got to keep a lot of digits in there, because if you just go, well, divided by 12 gives me 0.16, and you just round it to 0.1 or 0.2, you're going to lose a lot of accuracy. So always use a number on your calculator, don't round off too much. Okay, let's try our second example. Alright, this one, calculate the future value of an investment of $6,000 at 8% per annum for 3 years with interest compounded annually. Okay, instead of annually, let's make it quarterly. Let's make it quarterly. Okay? So we need to look again at the rate and the number of terms, and that's going to change this. I'm going to quickly write down here, compounded annually, got us 7,558.27. Again, just so we can compare our final answers. Okay, this number and that number are going to change, and this number is going to change. So let's have a go. It was 8% per annum. It's got to be per quarter. Okay? If it's per quarter, I need a quarter of this interest rate. That divided by 4, which is 0.02. Okay? That's my new interest rate. It was 8% per annum, it's 2% per quarter. 1.02. Number of terms. It was number of years, but now it's quarterly. So I need this to be the number of quarters in 3 years. Well, there's 4 quarters in 1 year, so 4 lots of 3 makes 12 quarters. So let's go 1.02 to the power of 12. Find our calculator again. $6,000 times 0.02 to the power of 12. And it gives me 7609.45. Again, rounding off to cents. Okay, look at the difference. An extra $50 just because I'm doing it quarterly instead of annually. You get more money the more often you compound. Just like that.